All right. You guys
Hey,
can hear
Ray.
me okay?
Yeah,
All
loud and clear.
right. Excellent, excellent. Okay, so yeah, we're gonna be doing a tour today. I'm gonna do a little bit of an overview of the node manager. Some of this will be familiar to those of you who were here with us last week. Let me get my camera on here. Let me see. Give me a second. Let me see what's going on. Okay. Yeah, that's fine. Okay, good. So you see I'm a real human. Okay, so we're gonna be exploring Node Manager. Some of you are familiar with that space, and then from there we're gonna actually explore some of the language models that we can deploy on the HyperCycle network, and then some really kind of cool ways of distributing some of that and moving it around. And I'm also making use of our H boxes. So Mauricio, the whole UI experience that we're going to have today is actually being hosted by an H2 on my network. And that's the UI that you'll see. So I just kind of, putting it to work and seeing what it can do. It's a different architecture. And so building out for different architectures in the ecosystem, right? Not everything is Intel x86 or AMD 64. Some things are ARM 64, Raspberry Pis, things like that. So we got to make sure that we can, play with everybody because we want as much compute as we can get. Okay, so I want to make sure that you guys can hear me. So far it looks good. I'm gonna get the chat window up so I can see you. I see Dave is saying yes, you can hear me good. Okay, I'm gonna share a screen now. Share y'all screen. All right, I'm gonna do an entire screen share. It's a lot easier for me. Okay, let me see. Let me know. Give me a quick hands up that you can see the screen. And I know that Libra, you were going to do something for zooming. So I also want to make sure that you guys can see the screen well. So let me know maybe in the chat or wherever you can that the screen is visible and that it's easy to read.
It's looking very good.
Okay, good. Thanks, Mauricio. I don't know what happened to Antonis. Are you still there?
I'm excited about this. I'm looking forward to see how the UI looks on the end of the Hyper AI boxes.
Right. It's the same actually. So this UI here that you see right now that we're looking at, the node manager here, the UI is no different. The stack is the same. So if you're on a Hyperbox or you're on your own node or wherever the node manager is running, whatever instance it's running on, and you're looking at it here through this port, it's the same. It's the same
But I
experience.
will identify, like, where do I find my Hyper AI box in this dashboard, for example? Maybe for the users also that have a Hyper AI box, like where do I identify my box in here and select it, for example?
Okay, well, I'll tell you what. I'll take you to. I'm gonna open up another link over here and go to my HBox home. But you see that I've really just gone to a URL. Okay, and if you notice up here, this address, this is the IP address of my HBox on my network. Okay, so I need to find out what that is, and the way that you do that, there's a number of different ways. But the easiest way, because you're an HBox owner that has that nice, cool LCD screen on it, you walk up to the LCD screen and you go into settings and you look for the IPv4 information on the screen. And that number is what you put into the browser here, and then you follow that number with this colon and the port number that the node manager is broadcasting and advertising its service on. Okay, make sure that makes sense to you guys. This port number here is 8006. So if you have an HBox and the HBox is on Wi-Fi or LAN and then the Wi-Fi is not a guest network, you can access this address from anywhere else on the network. You can access it from your phone, as long as it's not on a guest network. You can access it from a desktop computer. It doesn't really matter. So, and this is the port number here that you're going to. So the URL really is just the IP address of the machine, colon 8006. That's how you get to it. And then you're running and you're looking at your HBox. In this case, my HBox is also looks like it's tilling an ANFI. It's got nice uptime, got 92% uptime, probably better uptime than HMS. You know what's interesting? I'm going to say this: we've discovered something interesting in our CBNO program. So, let's say you're subscribed to HMS with your ANFI, okay, and that's now alive, and that status is tilling, and all that stabilized quite a bit over the last 2 weeks. So, hats off to the dev team for getting all that stabilized and working. So once the ANFI is tilling and stable on HMS, you can register it. If you come over here to this, to the home, and you connect your wallet, you're going to see the ANFI show up in the list here inside of this space. And you can actually register an ANFI to your node and enable it for function. Because the way that the node works, what the license is doing is saying you are licensed for operation. You are licensed to be a node operator. You're licensed to deploy AIMs. That's what that whole ANFI node factory is doing for your node stack. So what's interesting is that when that happens, the AIM starts to the ANFI starts to till on the box. However, let's say the box goes down. Let's say something happens to the node, or your network goes down, or you get an internet drop. HMS takes over. So you actually have automatic failover for your ANFI when it's deployed on your own node. So it's kind of a nice perk for everybody in the program. And at some point, as this opens up for everybody else to be running your own nodes, if you like, on your computers, you can run nodes on Windows with WSL. You can run it on a Mac. You can run it on a laptop if you want to. You can run it in the cloud. You can run it in a data center. It's quite diverse in its capability and where it could be deployed. That's part of what we're going through and making easy in the CBNO program. So back to our HBox here. So this is, as you can see, it's the same view. Here is the view. I actually have a connected wallet on this side. You can see all my ANFIs here and my registration capability. But back over to the HBox, this AIM here, I'm actually, one of the cool things about the node manager is it allows us to connect to more than one registry. So let's say you're a developer and you're building an AIM, for example, and you want to test deployment of that AIM and function of that AIM. I'm actually doing that right now. And in order to do that, what I had to do is come and say, oh, okay, I'm going to set the registry that the AIM deployment service is looking for the AIMs in to a local. I can create my own registry on the box or somewhere else on my network, and I can connect to it this way. So when that happens, you're able to develop those images. You're able to iterate, test, break down, spin back up, etc. And you don't have to worry about putting things up in Docker Hub or any other official registries or anything like that. So once you do that, the AIM is available here for deployment. You can come in. You can either deploy it here or through command line. There's some arguments of what the AIM is capable of doing. And then you can come in here to the running AIM and see what's up with this guy. When an AIM is running, one of the ways to test that the AIM is actually up and functioning is how it responds to the manifest. So the manifest is what the AIM is advertising to the node manager of what its capability and cost is. And that's the way the node manager in the future is going to advertise to the rest of the network of what its costs and capabilities are. That's how the rest of the network's going to know what's happening. So when you click here on manifest, you basically just get a JSON output of what's happening with this guy. Its version, some information about contact maybe, processing units, estimated cost per call, and what the public endpoints are and whatnot. So that's what's happening with this guy. And sometimes they do have health checks. You can come in here and see what the AIM is actually doing and functioning. This is actually a license status page that we're developing from one of our clients. So I just wanted to show you the HBox. That's what's happening there. Financials. This HBox has some transactions that have passed through it. Has a little bit of ETH in it, a little bit of USDC. This is all mainnet, by the way. Recent transactions. So these are transactions that have actually taken place on mainnet. And you can actually go straight into those transactions and look at them on Etherscan if you like. They're clickable right out of the node manager. It's really nice, and look at the sender and whatnot. And then the exchange rate, you can actually modify. You can tell the node manager what oracles it's using for its pricing and its comparison of HYPC, the USDC, etc. These things do need to be set for the node manager to handle a lot of the AIM operations. The monitor, again, we come through here. Again, I'm still on the HBox right now. I'm actually showing you the node manager through the HBox. You can actually see what its history with CPU usage, memory usage. You can see the HBox here. This is an 8 gigabyte, almost 8 gigs of usage and a 16 gig RAM space. And then this is the drive. It's about a 108 gigabyte drive. 48 of it is used and 58 of it is free. You see that here on the disk and the monitor and the metrics and whatnot. Logs are going to tell us a little bit about what's happening in the log space. It's kind of a little more under the hood. And you could use this when things aren't working or you're curious about what happened with the last AIM, for example, here, what ports it took, when it was downloading the image, the stopping of the container and all that kind of stuff. Admin calls to the page itself. Communication to the Merkleizer. So that tilling that the AIM is doing, that the node manager is doing for your ANFI, it's communicating with the Merkleizer. It's saying, hey, I'm proving myself. I'm proving my identity. And this is my signature. This is my hash. And this is the current block height that activity is taking place at. The node is making a copy of basic blockchain block data and storing it locally. It's not storing the entire Merkle Earth-64 data structure that's out there, but it is taking, it's like all the metadata, for example, and things like that, but it is taking some of that information and storing it locally for its own calls. So that's a quick tour of the node manager and what's happening there. I wonder if I can connect wallet and actually have multiple connections to wallets. Looks like I can. Okay, that's cool. Yeah, I was just curious if I can connect from multiple node instances to the same wallet, and I can. So you can see here, I'm still on the HBox. I just connected to a wallet that I use for testing. And here you see all these other ANFIs that I could register to activate the node here. If you look more closely right here where it says delegated CEO, oh, I don't know if you guys can see that. But the ANFIs that are saying delegated CEO are the ones that are subscribed to HMS. So that's an indication in this dashboard that particular license ANFI is subscribed to HMS. Just to let you guys know how that all works there. Okay, I'm going to come back to this guy over here, finish up the tour with the AIMs. So right now I've deployed an Ollama language model AIM. So we're going to do a little bit of play with that. And I can also search for anything else that is, for example, Ollama related. So there's a search box here. I have 2 Ollama-based AIMs. I'm playing with the newer one. It's an alternative AIM. There are different ways of loading an AIM and calling on your language models. This older one here is Python-based with a curl that goes out and grabs the model from the open Ollama repos that are out there. This second one is an Ollama-based image that pulls the model down. And you can change the model if you like. And I actually did. I wanted a model that was a little bit bigger. I grabbed the Gemma 3.4. We'll talk a little bit about what that means in terms of its capabilities and speed and everything here in a few minutes. And so now I'm going to switch over to the actual UI that is showing you interaction with the model itself. And if anybody has any questions at this point, I'm leaving the node manager. I'm going over to a UI that's been developed. It's available to our CBNO group to interact with these AIMs and these language models that are on the HyperCycle network. So one thing I'm going to say about UIs, HyperCycle's job right now, our primary focus is to build the internet of AI. That's a backbone. That's an infrastructure, right? So the UI, which is a user-facing experience and a whole, the way it's built, the way it expresses itself to you. The idea here is that the UI is connecting to the backbone, is connecting to HyperCycle. HyperCycle is not building UIs for people. That's what all the developers that are out there that are starting to come to us, they have their own applications, their own dApps, their own services and solutions, their own UIs, their own styling and fashion and etiquette. And they're going to embed these calls inside of that. What I've done here for the CBNO program and for you guys is to be able to demonstrate interaction with the AIM. So you see that we can interact with the AIM. You see that the AIM functions, that it takes payments, it handles and processes mainnet payments in USDC at this time. So that's what the UIs that you're seeing here are. But these UIs are fully capable of being anything you want them to be. You can dress them up and colorize them and fashion them and stylize them however you want. And the information for how to connect to the back end, to the node, to the AIM that's actually providing and advertising that service is what our documentation onboarding experience is now through CBNO, and as we expand that out to the larger community. Okay, so we're going to come over to our, so this is the UI that was developed by the team to test these models. So in this particular case, if you notice the URL here, this is the same IP as the HyperBox. So I'm actually running this UI off of a port that I created off of the HyperBox. I just wanted to do that just to see if I could and see and kind of stress test it a little bit and see what it's capable of doing and how it responds and whatnot. I'm going to do a refresh here, rebuild the page. So one of the indications that tells me that I'm actually connected to my HyperCycle node with this model is the model shows up in the model list, and then you get this prominent model, the model type and model that's here, that's actually ready for you to interact with. At the top over here, you have your wallet. I have 4 USDC in my connected wallet. I'm on the Ethereum network. I can add funds through here if I want to. So if I want to add funds to the node that is doing this work and pay it for the calls that I'm making to it, I would click here and add funds. So now what I'm going to do is I'm going to throw some test questions that I have prepared to test the model's capability. So can it answer the question, and how long does it take to answer the question? And one of the things to keep in mind when we're looking at this particular model, okay, so this is a Gemma 3.4b. I went over to ChatGPT and I said, okay, I'd like to compare this model to ChatGPT, a parameter comparison. What is the difference that I'm actually dealing with here? So I actually know what to expect.
Sorry to interrupt, Raymond. We've just got one question from Philippe that's come in. Are these applications available on GitHub? There is a couple on GitHub. This one isn't. Do you plan on putting it on there, or?
Well, actually, these are.
Oh,
but
they
they're
are
in private repos. Yeah, everything is GitHub. So almost everything that you see at some point is in a GitHub repo, whether it's a private or a public. Some of HyperCycle's backend is public, some of it's not. A lot of the UI stuff is private because it's being developed. It's really not for public consumption. I'm starting to put some of that, some of the work that I'm doing into a public space to make it accessible for the CBNO group. And we'll publish that out to a larger community as our onboarding experience kind of refines that and make sure that it's stable, right? Because you really want point-click experience here. Everything's got to work, and it's got to work the first time. So we don't want the public that's consuming this to have all these errors and problems and issues. So that's part of what CBNO is doing for us. It's working out the bugs in the onboarding process so that when we open the doors to everybody to spin up their own nodes and deploy all these applications and whatever's been done by the team, it's fluid and it works and it's nice and smooth. So that's one of the reasons things take a little while, because we're not messing around. We're pretty serious about the quality of experience we want our clients and customers to have. So we're not just going to push out stuff haphazardly out there. Okay.
And Reggie Classics, sorry, one more, Raymond. Reggie Classics asks, are the hyperboxes capable of running on unquantized models?
So that's a good question. Here's what the hyperboxes are capable of doing. They're capable of interacting with anything that is running AI inference on another data cluster, not locally. That box is not capable of doing any any real significant modeling or any of those higher compute and inference models. So, for example, if you want to interact with Grok, I'm going to be interacting with OpenAI here in one of the demonstrations that I'm doing for you. So that's when the calls are being handled by a wrapper or by something that's calling an API endpoint that's handling the actual inference, right? So one thing that, to that question, because when I first started looking at the H boxes and the HyperCycle ecosystem, one of the I'd say the beauty of it and one of the unique aspects of it is its capability of swarming, right? Its capability of aggregating compute around a task and executing on it and making use of all these edge devices, maybe someday on NewNet, right? Or something else on SingularityNet. The way to do that is for the agents to communicate with each other and aggregate their compute on a task, right? So that's in our pipeline. That is part of the development pipeline and the vision that comes out of the white paper for HyperCycle. So at some point, an HBox can contribute some part of compute for a larger request that the network is responding to. Okay. I hope that makes sense to everybody.
Yeah, he says he understands much better now.
Okay, excellent. Yes, fantastic. Okay, good. So coming back over here to this, so I said, hey, ChatGPT, compare the Gemma 3.4b model in terms of billions of parameters. Give me a good analogy comparison for a presentation. This presentation I'm doing with you guys. So approximate parameters of the model that you see me running, that you're going to see running here in a moment, is 4 billion. ChatGPT's version 3.5. Now notice we're at 5.1 already. I just noticed it just came out. And I can see they're competing with Elon Musk Grok because it's got an instant mode now and it's a lot faster. You can have deeper thinking and reasoning if you want, but it's quite responsive when even for some of the coding work and stuff that we do. It's 175 billion parameters that OpenAI. That's obviously a lot more. Rule of thumb, it's about 50 to 200 times larger than the model that we're deploying here on the box, and all this kind of stuff. Pocket calculator versus supercomputer, small village versus megacity, etc. So I'm going to come back to this model here, and with all of that said, it's impressive what it's capable of doing. One of the use cases that I see for the smaller models is domain expertise. So, for example, if you have a workflow that you're automating through HyperCycle and you're building an agent framework that's handling a workload for you, you're automating a workflow in some environment that you're working in or developing for, and you want an expert in a specific area that is well trained to respond to queries and other requests for intelligence and input that's happening. That's one of the places that the smaller language can excel in. You can actually train them to be who you want and what you want, and even bring prompts and specific questions and knowledge into them, so that you have responsiveness from within the network. You're not going to APIs and other compute providers. The network's handling it for you. So that's one of the use cases for smaller models, is the expertise and the focus, the more myopic focus that it can have on specific input queries. Okay, so we're going to come here. One of my test questions is list the layers of Earth's atmosphere and typical altitude ranges for each in kilometers. Felt like that was a good test of the system. So when I ask, anytime I'm hitting the game and I'm asking it to do work, in the way that the UI is presently developed, it's asking me to validate myself as the payee, as the one who has actually deposited money in the node. So it kicks up this wallet. I don't know if you guys can see this on your screen. This MetaMask signature request. Okay, good. I confirm that, and that hits the back end. It says, okay, yes, you are the paying customer. I'm going to do this for you. I'm going to do this job for you. And then we see what the model does. And then it responds. It gives us a pretty good response of what's going on. It answered my question. This is what I wanted it to do. And it did it pretty elaborately. Different ranges of the atmosphere, their thickness, and their altitudes. It's exactly what I wanted. So now I'm going to take it a step further, and I'm going to say, do me a favor and summarize the purpose of the ionosphere in 2 bullet points. So what I'm testing for here is knowledge and recall. Confirm that transaction. That hits the back end. If I'm watching my GPU and I'm watching my hardware, I'm going to see my GPU spiking, taking on the compute, and then delivering that response back to the UI for visualization to the UI for you guys. Oh, radio propagation. This is what it's designed to do. Space weather interaction. The ionosphere. I've been actually studying that on the side. It's a very interesting aspect of our atmosphere. Okay, now we're going to do some more mathematical type of questions. This is a reasoning math question that we're going to throw at it. So this question is saying, if a satellite is orbiting at 400 kilometers altitude with a speed of 7.7 kilometers per second, estimate its orbital period in minutes. So I've done this enough time to know generally what that should be. Let's see what we get. Accuracy at this level is really nice to have. Not all models can handle math as well. They all have their expertise, their pros and cons, strengths and weaknesses. One of the things about the Ollama, the Ollama system, I would have to say, the Ollama public repo of models that are out there, it's about right. This is putting it at 106 minutes. I've seen between 91 and 106 minutes in all of my calculations. So that's about where it sits. And then we're going to come over to a kind of robustness type of call to see how it handles a request for creating a JSON object with layers of the atmosphere. Come back in there, confirm. And what this will do is actually give me a JSON output that I could use in the creation of whatever application I'm building or whatever JSON output I'm doing, whatnot. All right, good. Thank you. Appreciate that. So accuracy, responsiveness, usefulness. Different models, have different strengths and weaknesses. Ollama is a big repo. It has a lot of different models with different parameters. And what's one of the cool things about this particular AIM, if you come into the AIM deployment, let's say I wanted to change the model that was running. If I come in here into the running AIM, this is the AIM that's running. I click here. I click on modify and I say, oh, I want a different model. I'll just pick some other thing that I've stuck in there. Maybe, let's see, how about a JAMA 3.1? Save the changes. That's going to restart the AIM. And I'm going to go take a look under the hood. I'll share this screen here in a second. There's actually, as a node operator, with some of these different kinds of AIMs that have large downloads, one of the things that, I don't know can you guys see this screen?
We can see your node manager screen at the moment.
The node manager screen, okay. How about this one? I don't know if I'm sharing the screen or a window.
Yeah. We can see the window now. We can see the code.
Okay, great. So what we're seeing here is this whole code output that we're seeing is actually on the node manager that has deployed the AIM. The AIM is really a Docker container. So I can go into the Docker container and see what the status of activity is in the Docker. So in this particular case, if I'm changing the model, it has to go out to the repo, pull another model down, and then I get to see the download progress here, for example, if you can see that. And then once the download is done, it launches the server that expresses the manifest that makes it available to the AIM process. So now I have a different model. I can come over here and I actually should see a new model showing inside of my thing, and I do, right? So that's awesome. I love when things work. Just kind of testing it, make sure it's still functioning properly. So we went from a 3.4 to a 3.1. There's all kinds of interesting models in the Ollama space, actually. And notice this actually formatted the JSON has a number of different ways you can format information, and this one did it in a different way. I always find that interesting, the way it does that. Okay, so that is the Ollama AIM that's in there. I am using the Ollama alternative AIM that gives me access to these other models. Notice right here where it says GPU plus. When you see that symbol in the label of an AIM, what that tells you is that the deployment of the AIM is not making a GPU mandatory, but it will use it if it's there. Some of these AIMs out here, like for example, let me go out to Turtoise. This guy. Notice this one here. It's a large, almost 5 gigabyte image, and it's telling me that the AIM is looking for at least 8 gigabytes. So if you have an 8 gigabyte card, it won't work because the system is actually using some of that space, and you end up only having like about 7 or 6. So it'll actually, the deployment will error out. It'll fail because it can't grab the 8 gigs that it's asking for in its label. So just making that clear to you guys if you ever run into that situation. That's what that's all about. Okay, so what I'd like to do now is play with another AIM. I'm going to go ahead and tear this one down. You can have multiple AIMs running if you want, but for the purpose of this experiment and the way the UI is set up, so I don't have to change any variables, I am going to break it down and stay on my same port. Okay, so this is the Light LLM AIM. This is a wrapper. This can run on the H boxes. This can run on really almost anything. It's not using a lot of compute and a lot of CPU power. It's really just acting as a gateway to the APIs, other language models that you might want to use. So in this particular case, what I'm going to do is I'm going to change this to GPT-5 Nano, and I'm going to provide it with my own API key that has a fixed balance for all of you who might want to copy it. You can use it until it expires. So it's just a test account that we're using here to make sure these things work. So in this particular case, what I'm doing is I'm wrapping an API key and model in this AIM so that I can talk to ChatGPT through the AIM at this model with this OpenAI API key that I've generated. I'm going to deploy this guy. Downloading. Won't take too long to download because it's a fairly small image. And then once it's done, we'll check the manifest and make sure that the manifest is clear. This is a good time for questions. If anybody has any questions about what they're seeing.
I've got one question, Raymond. Obviously, you said about the limitations of different LLMs and their strengths and whatnot. This is the idea of these nodes is deploying to the Internet of AI. So theoretically, if you were a developer and you've built your LLM, rather than training it on billions of compute tokens, could you instead deploy it to the node and have it draw intelligence from other LLMs that are at that stage?
Okay, rephrase that one if you did.
Sorry?
Just rephrase that question for a moment. My brain sort of kind of it froze for a moment.
So I'm a developer now. Let's imagine I'm a developer and I've got my LLM and I've gamified it and it's running on my node, but it's not the smartest. Can I purchase from other AIMs that are deployed on the network so that my LLM can gain its intelligence?
That's an interesting. So one
Because
of the
that
ways to
should be
answer that,
possible.
yeah, the way intelligence works is it's an interesting weighting process that the network is doing when it's looking at how aims are performing and quantifying the quality of the work that they're doing, the latency and the amount of time and cost that was associated with the work that they were able to produce and execute. That all that information is being monitored and tracked by the network, so you're always getting the best cost and the fastest speed, right? So if you're deploying a model that you see has a fixed parameter and constraints around its expertise and what it's capable of doing, then you have to ask yourself, is that model contributing to a swarm response where you have a more intelligent response because that model is contributing its power into that response? Or are you training that specific instance that the model is running on to have more information, to be smarter about a specific subject matter or topic? There is a way to train these guys, and you can set these aims up for that to happen. You can have aims that are training other aims and things like that. So that's the way I would answer that question. It's one of those things that we're evolving and developing as we move along with this one. So the way that we approach something like that is going to hinge on how much does it cost, what are the cost routes for that, what are the latency routes for that, how efficient is that, and what is the user experience that I'm wanting to have, right? So how much compute do I need for that? How spread out am I? What does my network look like? How responsive is it? And all that kind of stuff. So that's probably right now the best answer to that question that I can give you. Okay, I'm going to show
Yeah,
you
that's
guys
a good answer. Thanks.
it's
I've got
decent.
one more
Yeah,
question. Sorry, Raymond, from
yeah, go
Reggie.
ahead.
He says, I saw there was a specified GPU for a llama. Can you specify RAM and GPU VRAM for models? It does vary, doesn't it?
Yeah, it does. So like for example, the Olama aim that's not the alternative aim by default is going to throw up a Gemma 22B. That's a 2 billion parameter model. That guy is going to want 8 gigs of VRAM off a GPU or 22 to 32 gigabytes of system RAM off a system that doesn't have a GPU and is only running CPUs. Okay. So what happens is when the CPUs are taking on that inference and then that compute workload, they need more workspace, and so they take up more RAM. What the GPU is doing is it's consolidating the workspace by the way that the hardware is approaching the processing of that job. I don't want to get too technical. Tensor cores and CUDAs and all these different things that are happening, like Grok, for example, and how its language processing units are handling those calls versus an NVIDIA GPU versus an Intel Arc GPU and versus some other NUC processor. They're all handling those things differently. Certain chips are more they're more specific in their ability to process a specific kind of algo or AI inference, right? It's part of what makes Grok so interesting. Yeah, so I hope that answers the question. There's a one of the things that I'm doing as I go along just with this program, is developing a table of the models that we're running, the aims that are running that are available on the network, what their minimum requirements are for stable functioning but high latency, and for high performance, low latency functioning, those two variables. So there's going to be a web page that we can go to that tells us this aim performs at this level with these specs get ready. You're a node operator. This is the hardware you need if you want to monetize that capability and advertise it to some marketplace or to the network. So that's part of what this program is doing, is it's compiling that information and putting it into a format that anybody could use. A salesperson can use it to automate workflows and budget out how they're going to build with HyperCycle, all the way down to the, I want this one AIM because it's highly monetized, it has a high profit margin, I want to make sure I can run it and make it available 24/7, 365. Right? There's different use cases for people want to be able to do. I did find a link. Can you guys see this Ollama library link? Is that visible to you?
Yep.
Yeah. Okay. So the Ollama aims that we're playing with here, these guys. Let me go back to the Ollama aim. This model here, this little model field that we can modify and pull down the model that we want. Those models, when we start looking at what kind of models do we have available, we come to this Ollama library and you find all the cool models that we got, including DeepSeek R1. Here's Gemma 3. When you click on the model, you see these names here. This look familiar? That's the model name that you plug into the AIM model field to pull this model down from this library. So that's kind of how you learn about different models, how many times they've been downloaded, how many times they've been updated, how big they are, the different parameters for these models. There's obviously quite a few, and you can push, you really test your rig out if you're a node operator and find out what happens if I put a 27 billion parameter on my GPU. Does it tank? Does it freeze? Does it burn up? What does it do? So that's the kind of testing that happens within development of these things. So I just wanted to show you guys that this is a place you can come to find out more about the kinds of models that can be deployed through that specific AIM. It's a very flexible AIM. It was well developed to make sure that we have that kind of flexibility. So I'm really stoked to see it. Okay, where am I going here? All righty, so we're coming back over here to my node manager and to my deployed AIM. Okay, so it looks like my light LLM AIM started up, and I'm going to go to the manifest. This is what tells us what's going on and how to talk to this particular AIM to make sure that it's actually running. If you come over to the to the label, it's going to tell us a little bit about what the environmental variables are for this particular AIM. Okay, so now we're going to come over to our GUI and see if the GUI picks up this new guy. It does. Awesome. So the same user interface that we were using to talk to the Ollama AIM is also capable of talking to this AIM. And we developed it to be hybrid in that way. This is still running off the HBox. So this user interface that you're seeing here is still running off the HBox. And now when I create a query, I'm actually creating a query against OpenAI's ChatGPT, okay? So now I'm going to do the same queries to see how they respond. And I'm open to queries that you guys might have. So feel free to ask for any queries that you might want to test out here. List the layers of the Earth's atmosphere and to look altitude ranges for each in kilometers. Pretty basic query. Cool, and this is ChatGPT's response to that. We can actually see what this looks like from the OpenAI side. And you come over to the usage. So this is the usage that we've done here so far. How much has been spent with this API key across this particular time frame. And I can go month to date to give us a little bit more information. October usage there. So this is the AIM front end hitting the API endpoint that you've set up with your key on the backside. Just to make the connection and see how that's working. I want to see how it handles this specific mathematical one, see what its output is. Saw there was a specified GPU for Llama. Can you specify? You also said the hyperbox good for swarming base. I'm also would be possible to extract certain part. I'm also using Grok using Gemini coding gem. Here we go. Okay, so yeah, so we have a 92-minute result from ChatGPT within that 10-minute range. And let's see how it handles this guy. Interestingly enough, it's not that much faster. I think we would have to hit different kinds of queries that are more complex to really notice the difference between wrapping OpenAI and getting and our own model that we were hosting ourselves. But yeah, so that is the demonstration. We have the two aims that we've shown you. One is a wrapper for various different models that are out there. And actually look at all the different models. So these are all the models that are available through this wrapper. You can see it in the models endpoint. Quite a few of them. There's also a Grok model that's out there as well we can use. I've myself just started experimenting and exploring Grok. So I was gonna explore it here with you guys. We do have a Grok AIM that makes use of the Grok network. Very similar to this light LLM AIM. It's just wrapping an API endpoint and giving you access to that infrastructure.
And when you're saying Grok, do you mean GROQ, the Gronk, or Grok?
Yeah, GROQ. So we have that in our registry.
Yeah, I know a lot of people are interested in that.
Yeah, this is the Grok AIM.
Has it had any pools yet, Raymond? Is it being used or?
It has 128 pools. So it has been used. Yeah, you can see all the pool counts here. Like buoyancy AIM 294, cost tester a bunch for testing. Grok has 128, HyperY 61, the Tiller almost 2,000 pools. The light LLM AIM quite a few. Quite a bit of usage across those guys. The Llama AIM has 842 pools. The alternative approach, which I think is actually a little bit faster and more reliable, has fewer pools, but it's also a newer update and alternative that's there as well. See, that's one of the cool things about this particular list is you can see what's in use. This AIM here is the AIM that I was talking to Mauricio about. So it's a small, lightweight AIM that the Hyper AI boxes can handle. And what it's designed to do is make a storage available that is attached to the node that it's running on to the HyperCycle network, and it's doing it through FTP calls. So that's one possibility as well. And building out solutions is using all that amazing storage that the H1s have. I think they have I forget, it's a very large storage device.
Reggie asks, what's Grok? It's an American AI company. Correct me if I'm wrong, Raymond. They've developed specialized hardware, which is a language processing unit, and they're actually getting closer and closer to. Well, no one's close to NVIDIA, but they are taking a fair chunk of market share at the moment.
Yeah, well, they're actually faster. That's one of the reasons they've come up so quickly. They're about 10 to 25 times faster than an NVIDIA GPU in the class. So it's worth exploring. I'm actually developing a UI for that aim now. I might even just use the same one that you guys saw. Just got to look at what the hooks are. Just starting to play with that aim. Maybe we'll demonstrate that next time and do some performance testing to see how fast it is on more complex queries against these other models. We can test across all three. It's really the way to do it. But yeah, it's out there, and because its hardware is approaching the compute differently than the more traditional GPU hardware is doing, and as a result, it's able to process more quickly. I use the analogy of pulling a basketball through a hose at high speed. That's essentially what it's doing. Because it's very efficient and low cost also. The thing about Grok is the hardware is part of some private, data center, globally distributed entity, right? So the hardware that's crunching that and doing that LPU for you is out in the world. The API is open for anyone to use, including our nodes, for their own intelligence and entry and sharing that information within the network, so that the calls that are happening between agents are happening in the HyperCycle ecosystem. As part of what these aims are doing, they're making sure that real world information can come into and interact with the intelligence of the network as it develops and evolves. So you need things that are pulling data in. And then, of course, you can silo if you want. HyperCycle can have its own language model cluster that's specifically trained by the community on whatever topics and subjects that they want to have more expertise in. It's one of the cool things about having your own network.
We've got a couple of people typing questions. We've got 5 minutes left, so hopefully we should be able to get them answered. Robin asks, is the storage aim you just mentioned where you would keep your own data if you fine-tuned a model on domain-specific data, like you mentioned in the beginning as a use case for smaller models?
Yep, that would be where you can store your own data. One of the things that we want to look at when we're thinking about the security of data, because privacy is obviously a really big deal. I'm gonna share with you guys something. Just give me a moment to kick it up. It's something we want to be very aware of. Security layers. So there's a lot of different layers that you can add, and when it comes to security, it's always about, at the end of the day, deterrent. Because if an actor is well funded and persistent and convinced and driven enough, they'll do everything they can to get through. And it then becomes a matter of how costly is it to get through the different layers that you create. In most cases, if you make it costly enough, it's cost prohibitive for that threat actor to come over to your attack surface and try to find a little hole and get through it. So the more layers you have in place for your security, the harder and more expensive it's going to be for them. So you're really just creating a high level of deterrence, basically, at the end of the day. So there's different layers that you can put in there. Go ahead.
Moonrider asks, can you link your nodes together to enable parallel processing against a job submitted to a name?
That is the beautiful magic sauce of HyperCycle. That is what's in development. Yes. So the whole idea is as the network starts to come online with aims, and the node operators are online with aims, and the HyperPG, it's got its clusters, and other marketplace, everybody's coming online. And what starts to happen is the aims start to advertise their capabilities to each other. I can do this. Oh, you can do that. That's really cool. I really need that. How much does it cost? Oh, I found someone else that does it cheaper. Oh, sorry. And so there's a database, I guess you can say, and an awareness and intelligence of what the network itself is capable of with everything that's there. Everything's advertising its capability. Once you have that in place, and that's what's in the development pipeline now, because that's in the white paper. It's the thing I'm the most excited about. That's what we keep seeing in Thomas Frey's futurist articles. All the cool things that this network is capable of doing with the way that it's being designed and engineered. Then the answer to your question is, they not only can you link them, they link themselves, right? Because they're advertising capability to each other, they're also advertising their location, their access, their cost, their identity, and all the cryptographic proofs that are involved in that process to make sure that only the ones that are paying for it get it, and only the ones that are authorized get it, et cetera, et cetera, et cetera, right? The right, all the right proofs that are in part of that process. So I hope that answers your question.
He also says he would want to parallel process against his own nodes or her own nodes. Apologies, Moonrider. I would want to parallel process against my own nodes, Node Factory. Could you choose to do that?
Theoretically, yes. But then the question really becomes now, okay, so if you're going to start to kind of, because now what you're doing is you're saying, hey, I own this node and I want to be in control of the work that it does. So now what you're also saying is I need to be in control of how you advertise yourself to the network and how you respond to the network's demands on you. So then architecturally and theoretically, that capability is there. But whether or not that's built into the APIs and built into the logic and everything that is happening, that's another question. Because that's a feature in a sense, your capacity and your ability to do that. Because of the open source, decentralized nature of this project, okay, that things will actually become more open source than they are now. What happens is you start to see more freedom and flexibility in what you can do. If you don't see what you like, you can make it. Just build on it, extend it, add it to the repo, and now it becomes part of the capability of the network, and people can choose to deploy it or not, right? That's where in the future network forks can come from. If you get a big enough chunk of the community that says, well, I like the node doing this, and I would like to continue doing that. And then another part of the community says, no, I have an ethical issue with that. I don't want to do that. Then you get natural forking that starts to happen, or clusters that start to develop within the ecosystem. Depends on how you look at it. So yeah, I hope that answers your question. There's a lot of different ways to approach that.
We still have a couple of people typing. Scott the G's been typing for a very long time. So either they're leaning on the keyboard or you've got a very tough question to end the show on. Padre Mist just managed to jump in now. It is being live streamed to YouTube also by Libra Lives. And thank you very much for that, Libra. And the recording will be available on YouTube, both on Libra Lives YouTube channel, and there'll be a podcast section on the HyperCycle YouTube channel also, where you'll be able to watch a recording. Scott the G. Sorry, Ray and Antonis, I'm curious about the monetization of node factories in Node Manager. I invested based on a model where there were node owners and hardware providers would receive a percentage of revenues from the use of our node factories. For node owners like myself who have no interest in becoming a developer nor investing in high-spec rig, I have a few questions. First off, with what Raymond demonstrated, okay, so he's not happy. While it's pretty cool, what is the addressable market? How do we generate revenue or extract value from my investment in HYPC? So the purpose of Ops Corner is it's a demonstration of a technology to give validation to it, for one, and two, it is targeted towards those who want to get more hands-on or want to network with people who want to get more hands-on. Using Node Manager is optional, but it's definitely a tool more designed for people who wanted to be operators or developers. If you don't want to be an operator or developer, that's fine. You can designate to a pool, like currently HMS. But in answer to your question, in who would care, it is still important to you because the work that's being done to make this Node Manager streamlined, smooth, and intuitive means that there'll be more operators that come into the marketplace, and the more choice you have, tends to be it's more options for a node factory owner to deploy with. There'll be different aims. It's just giving a base work for people to build on, really, and giving you more places where you can park your nodes other than what is currently available. So I hope that answers your question.
Yeah, I hope that, and those are good questions, Scott. And you know, some people don't care at all. They're just like, hey man, I want to point and click my way into some, you know, passive income revenue pool and watch the money come in. And other people are way down in the gears and way down in the trenches, making all of that possible and everything in between. So in this particular world, the revenue income streams are multifaceted. You get the HMS proof of concept now. And as more compute happens and more work is done there, that revenue will start to increase. The more nodes are put to work, more clients, more customers to the network. As a node operator, with what you're seeing on the screen, you can participate and deploy and advertise yourself to marketplaces that are monetizing the opportunities that the node is making possible. So, for example, right here, all this little number here, you'll check in some morning drinking your coffee, and it's got 3 zeros behind it because somebody just paid for all this compute on your node. But there'll be a much different dashboard that marketplaces are using to give you all that information and be able to withdraw the revenue. But that's what's happening. Everything you're seeing here is mainnet. This is real money. And it is taking real payments, and you can monetize things. So any application or service that the node is capable of performing that can be deployed by the node and advertised to a customer that's out there, either an A to A point, a point A to B sort of relationship or a marketplace relationship. You have underneath you as a node owner licensing the capability of monetizing that opportunity. So again, it really just depends on how much time you want to put into it and where your focus and interest lies. Some people are going to be interested in going deeper and being under the hood in the more developer builder style. Other people just want the HMS experience and the marketplace experience that's coming as well. I'm really excited about. So I hope that answers your question, Scott. And Jungle Mike.
So we've got one from Manny Pebbles. Approximately how far off are we from nodes being able to autonomously call on other nodes? You said it's in the dev pipeline. Do we have a time frame for that?
You know what? I don't want to say anything. I don't want to put myself in trouble. I can speculate on it, but it really depends on a number of factors that can change overnight. So I'm not going to say anything. Let's keep talking about it. It's coming. I wouldn't be surprised if we start seeing some of that capability next year. Obviously, I don't know what point in the year. I would say the second half of the year we start to see some of that stuff come online and play with it in beta. But it really depends on the bandwidth, the resources, and the path that we take, and what we prioritize in our feature set, and what we want to actually do, and how big of a team there is doing it. It's all about the space that we're in, the funding that we get. The engineering and the vision is very clear. The roadmap is there. The white paper is really clear. What we're capable of is really clear, and our ability to translate science and vision into code is also evidenced. We're demonstrating that, right? A lot of companies in this space attempting to do what you see us demonstrating, they're out of business. It was too much for them. So hats off to HyperCycle for being in this for over 2 years now and still going at it and still bringing the roadmap closer and closer to us every day. It's a lot of work. It's a lot of things happening out there. And there's a lot of people doing interesting things that are similar. We're still, in my opinion, just light years ahead of a lot of the stuff that's out there. And I think if we keep developing and building along this path and taking on and really keeping ourselves agnostic and open and flexible. One of the things I like about the way Tufi is leading the company, if you noticed, he's not really here to constrict the flow of information and wealth and energy on the planet. He wants to see it move freely and organically. And that is, to me, the biggest invitation for wealth and the movement of wealth into our center and out to the edges that we're all a part of. So I hope that that helps. Yeah, I get you. I get you, Scott. I appreciate you.
Yeah, and he was asking, will we be facilitating the connecting of node factory owners and operators? That'll be HyperPG's role. They are in the business of connecting. So yes, there should be advertised pools from operators. And if you want to deploy your node with them, you'll make an agreement. We can't say what these agreements will look like. There's data being collected from HMS constantly, so that we can start getting some idea of what these agreements will look like between operators and factory owners and AI developers and so on and so forth. Padre's asking about the HMS Rev display. That's Azaline's meant to be doing the release notes. So my assumption is today or tomorrow. But I also said that last week. So I'm hoping, as much as I'm saying that is today or tomorrow. Yeah, that should be imminent. We still have a few more people typing. We are 10 minutes over, so we'll answer these last couple of questions, and then we'll have to be for next month's episode. Dave says, excellent job. Have a great day. Thank you, Dave.
Thanks, Dave. I appreciate you guys. Thanks for coming. Thanks for checking us
Padre
out.
Says, thanks, and hopes the issue, I assume he means the HMS Rev display. Yeah, we all do. We want to see what that number is. It's Tranche 3 is live now. Yeah, Tranche 4 is on board and Tranche 3 is live. So I'm definitely very interested to see, especially with the volume of nodes that are in now. Scott, thanks for the presentation. And Dutch Breeze also thanks us. Yeah, have a great day, everyone, and thank you for all the kind comments. And obviously, there is no bad questions. They're all good questions. We keep them coming. We do enjoy answering them. And if we do disagree with you, it's not it's a friendly disagreement. It's all friendly. We're always happy for the questions, even the tough ones.
Right. I mean, our job, what I was hired for initially, is customer success. So the more work we do in making this work for you guys, the better this is for everybody. That's why, if you've noticed at HyperCycle, we haven't really left anybody behind. We give everybody a lot of space to catch up and know where we're at. There's a lot of socials and communication happening now. The company and the team is very engaged in making sure that the world knows about us, that you know where we're at and what we're capable of doing. We're supporting you with C8. We're supporting with the education that's coming down the pipeline. I like seeing it, because that really all these pieces together are what is necessary to build a community like this. So we appreciate your concern. We appreciate your questions, your feedback, positive and negative. We need it. And we appreciate overall the members of this community that are just there day in and day out, your loyalty, your conviction, believing in us. And some of you are bringing people in that are builders. You're bringing people in who are seeing what we can do. I'm meeting them almost every week now. There's new use cases coming in, everything from universities to medical institutions, laboratories, all kinds of interested parties that are actually onboarding with us and learning how to build with us so that they can provide those opportunities and services, not only to themselves, but to the larger network, right? As those opportunities that develop within those more siloed environments, they also become capability for all of us. So I love the way that HyperCycle just keeps open arms to all of this. And I think sometimes that's what can sometimes be confusing, is just how big those arms are. we're putting our arms around a lot. And so making that clear, and also at the same time having a clear core and center and hub for us to stick to and branch out from is also part of the work that we do every day. So I really appreciate you guys. Thank you very much. Thanks for coming. We'll see you guys soon.
Thanks, Raymond. That was an excellent demonstration. Take care, everyone. Bye.